next question, question 8. Let's read. We have a graph for y equals f prime x, right? Okay, the graph of y equals f prime x is shown. So this is f prime x, and then the curve intercept x-axis right here, and the minimum is at 3 minus 1. All right, write down the x coordinate of the point of inflection on the graph, original one, fx, not f prime x. So let's revise a bit. All right, okay. If you have, for example, if you have this graph, okay, for example, don't write it in like, okay, may I write it, okay, more general, x and y. And then here, this is your maximum. Just analyze it. This is your minimum. Can you tell where is the point of inflection? What is point of inflection? Is the point where the concavity would change, like from upward concavity, positive concavity, change to downward, negative concavity. So this is or the other way, so from downward to upward. So this is negative concavity or downward, and this is upward, positive concavity. So it changed the concavity somewhere here. So this point is point of inflection, right? And then shall we analyze this way? At maximum point, you would get gradient here, m equals 0, and at minimum point, m also 0. What about before the maximum point? You would get positive gradient. After maximum point, you would get negative gradient, right? So this is positive gradient, and then 0 gradient, and then negative gradient. How the gradient change? The gradient change decreasingly, right? That's why you get negative concavity, because the gradient is changing in decreasingly. And look at the minimum. Before minimum, the gradient is negative, right? At minimum, gradient is 0, and after minimum, gradient is positive. So the gradients change increasingly, right? From negative to 0 to positive, the gradient is changing increasingly. So the concavity here is positive. So positive gradient, positive concavity. What about this point of inflection? Is the point where the concavity is changed. Therefore, this point of inflection, it would be change. It would be change, the point where the change of gradient of the graph is rate of change of gradient of the graph equals 0, right? Okay, word by word. What is gradient of the graph? Gradient of the graph is the rate of change of the graph. Therefore, this word is f prime x, okay? So when you do rate of change again of this whole thing, so it means you differentiate this one again, right? So you would get f double prime. Here you would get f double prime. Because of this one, we would get f double prime, and then equals 0, okay? So if we plot, this is fx, right? This is fx. And what if we plot f prime x? F prime x is the gradient of f of x, right? This is the gradient of that one. So look at the minimum. Gradient at the point minimum. Okay, I would use the same scale. The gradient would be 0, right? May I write it in like better way? Okay. Better. See? Okay, at the maximum, gradient is 0. Therefore, the graph would cut this point right? This point, okay? At the minimum, gradient is also 0. The graph would cut this point. All right. And at before maximum, you can see the gradient is positive, right? This is positive gradient, this is positive gradient. So the graph would come from this way, okay? Come from this way. And after maximum, after maximum, the gradient is negative. So this is come for positive, and then at maximum, gradient is 0, and after maximum, gradient is negative. So you go down for the negative value here. This is positive value. And then you have to go up again to cut this point where the minimum occur. The gradient would be 0 again, and then after minimum, the gradient would be positive again, so up there, right? So your graph would roughly like this. Okay? And what about this one? This new minimum occur here. What is it? This is when gradient of this graph equals 0, right? And what is gradient of gradient? Gradient of gradient is concavity. So this point is where concavity equals 0. So it means this point indicates point of inflection of the original graph. Okay? So here I can say this is point of inflection. And this is maximum, this is minimum. Okay, so let's go back to our question here. What can we tell? This point is where point that f prime x equals 0, right? This point is also f prime x equals 0. But this point is the point where gradient of f prime x equals 0, which is f double prime x equals 0, which means this point is the point of inflection. So question A, write down x coordinate of the point of inflection. So x coordinate is 3. All right. Question B, the shaded area enclosed by the curve y equals f prime x and x-axis and y-axis is 0.5. And given that f0 equals 3, 5, f1. So should I write it up here? Okay. So area shaded would be integrate of f prime x dx from 0 up to 1. So 0 to 1. So when you integrate the derivative of f, you would get f, right? So it would be fx from 0 to 1. So you get f1 minus f0. And the area is 0.5. I write it down here, 0.5. f1, you have to find it. f0 is given. So f1 minus 3 equals 0.5. Therefore, f1 equals 3.5, right? So we can find B, f1 equals 3.5. Okay. And then C is given that area enclosed by the f prime x and the x-axis between 1 up to 4 is 2.5. Okay. 1 up to 4 is 2.5. So this area. So may I would say area enclosed, it would be integrate of the top function subtracted by bottom function dx from starting point 1 to 4. What is the top function? The top function is this line, right? This line is when y equals 0. And then the bottom function is this line, which is y equals f prime x. Okay. So you're going to get integrate of 0 minus f prime x dx from 1 to 4. Okay. So it's just minus fx from 1 to 4. So you're going to get minus fx4, minus F4 minus F1, or the other words is F1 minus F4. So I can say F1 minus F4. Okay, and may I rub this one out? All right. And they said area is 2.5, so 2.5 here, and then F1 we just found it is 3.5 minus F4. So you can find F4 here. F4 equals 1. Okay, last one, question D. We have to sketch the graph. We have to sketch it between x equals 0 and 5. So you need to be careful. You have to find value of y when x equals 0 and value of y when x equals 5, as well as the boundary of the graph that you are asked to draw. Okay. So let's go back to take a look on the f prime x. Here, may I rub it out? Rub it out. Okay, rub it out. Rub all out. All right. And here, here you know, m equals 0. I mean m of fx equals 0, right? We're gonna find the graph of fx. So this point, gradient of fx equals 0, and also this point, the gradient of fx equals 0. And how the gradient change? It's changed from positive gradient to be 0 gradient and to be negative gradient. So positive gradient, 0 gradient, negative gradient, positive, 0, negative. So this point, maximum, right? So this point you have maximum. Just note it down. This is your maximum. And look at this point. Oopsie, this point here. Gradient is 0. Before the point, gradient is negative, right? It's in the negative region. Negative gradient change to be 0 gradient and change to be positive gradient. Negative gradient, 0 gradient, positive gradient, right? So negative, 0, positive, you will get minimum. So this point is minimum. Okay. And also this point, we just found it. It's, what is it? It's point of inflection, right? Okay, just write the information down. Maximum is when 1 comma, minimum is 4 comma, and last one, point of inflection is 3 comma. Okay, so you need to find value of y when x equals 1. You found it here. What is it? Still remember? 3.5, right? So this is 3.5. Okay, and then value of y when x is 4. Here, we found it here. What is it? 1, right? So this is 1. Okay, right, 3.5. This is 1. Okay, and one more. Can you find? Can we find the value of y for point of inflection? Do we have the original function? No, so we cannot find this one. Okay, so that's it. That's all we can find. Can we find the value of when x is 0, what is y, the left boundary, and when x is 5, what is the value of y? Can we find this boundary? No, because the function is not given. But generally, when you draw the graph and then the domain is given, that this is what you have to find. So actually you have to find the boundary, most left and most right. All right, so this one you just cannot. Okay, so the graph that we can draw, may I draw it here? Okay, so this is 1, 2, 3, and 4. So for 1 you will get maximum at 3.5. So this is 3.5. You will get maximum. And for 4 you will get minimum at 1. So this is 1. And then try to make this graph to be maximum. and minimum. Okay, may I rub this one out, and then here. Okay, if we finish at this point, what's wrong with it? Here, first of all, you don't complete the whole graph. Here, this one you don't write x and y. Okay, it's very serious. You need to write it down. Secondly, you don't write not you, me. Okay, I don't write the scaling properly. Like this is 1, 2, 3 and 4 here. I have to write it down properly. And 3, we have to draw the graph in this interval. It's set here in this interval, but I don't write number 5 here, and I have to like roughly make it on number 5. And more importantly, here is beyond 0, so we have to fix the graph a bit. Okay, all right, here. Okay, may I this is, let's say 1, 2, 3, and this is 4. Okay, so we can rub 3.5 out, and we should write it here like 1, 3.5, and then don't forget to write that y, x, and here this is 5, and it's roughly at 5 already, so it's good enough. Okay, this is 5, and we have to rub out the negative graph here, the beyond 0. Okay, so I have to rub it out, not entire stroke. So here, rub it out. May I zoom in a little bit to rub it out? Okay, better. And let me be clear, we don't know actually where is cut the y-intercept, so you just write it down. It's just roughly graph here. Perfect. Okay.